We'll talk a little bit more here now about complex numbers. We've already kind of introduced the idea of complex numbers before, but in MATLAB there's just a little bit more that you can do with it. So clearly, complex number is, I say clearly like everybody knows, but a complex number is a number that has a real and imaginary part. So complex numbers have a real and imaginary part. So that means that I can graph them on a real and imaginary complex plane. So like you do number lines in grade school and they're like, pick the, 3, and you're like, there it is, and you label it, or whatever, or maybe you are in like really advanced something and you're like, look, these are all the numbers greater than or equal to 3, all right? So what you were looking at was the real number line, that was this guy. So 1, 2, 3, you were going like this, all right? And you didn't realize that there was this mischievous imaginary axis crossing there that you could have used if you wanted. Got it? All right. So let me take this guy's away. So anyway, you have a real and an imaginary part. So if I ask you for the square root of a negative 25, hopefully you realize that you can't take the square root of a negative number, but actually you can, but it's 5i. And I is a special number in math that represents the square root of negative 1, unless of course you're an electrical engineer, in which case it's j. But I digress. So if I was going to plot 5i on my little chart, it actually has no real part. Do you see what I'm saying? It's entirely imaginary. So I go 1, 2, 3, 4, 5. So this is something that you could do in grade school, is have kids graph imaginary points on an imaginary plane, and they would get a giggle out of it because it's kind of funny. So there's my imaginary part, and that's the whole point. That's 5i. Now I could have a point that was more like 6 plus 2i. Now this is a little bit more complicated, but not really. But it's 1, 2, 3, 4, 5, 6 along the real axis, but then it's 2 up along the imaginary axis. So 6 plus 2i would be that guy right there. Make sense? All right. So if we gave you negative 3 plus 4i, could you graph it? So again, take a minute, pause the video, give it a shot, see if you can graph minus 3 plus 4i. You're like, sure, 1, 2, 3 backwards, then 1, 2, 3, 4 up. And indeed, there's minus 3 plus 4i. Alright, and one more for good measure. Let's do, wish I had a different color. We'll do this guy. What about minus 4 minus 7i? I'd be like, alright, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. So 4 over, 7 down. So that's minus 4 minus 7i. Okay? So those are a bunch of points plotted on the complex plane. Copy that? Copy that. Alright, so complex numbers, they have a real and imaginary part. So now if I go type the square root of negative 25 into MATLAB, it's going to come up and it's going to say, look, there's my 0 real part and my imaginary part is 5i. Copy? Alright. So if I wanted to, let's say I wanted to put some of our, so we had 6 plus 2i. If I wanted to put one of these points in here, call that point A, I could just say, what was it, 6 plus 2i? Yeah, 6 plus 2i. And it actually shows up. I don't even have to say times I. I can, 2 times I, that actually works. But strangely enough, MATLAB lets me get away with this. It never lets me get away with anything else. So if I just wrote 2a, it's going to yell at me. You'd be like, but 2, it's 2a, 2 times a. It's like, no. And it's like, but you just let me do it for 2i. It's like, yeah, I know, but shut up. So, whatever. But there it is. What else did we have? So we had minus 3 plus 4i. And you can just type it directly in, minus 3 plus 4i, and then we had minus 4 minus 7i. And that worked, and it was so super happy. And look, it didn't even yell at me. I love it when MATLAB doesn't yell at me. If I want to be super obnoxious, or I could say complex 6 and 2. And that actually gets me the exact same thing. Hold on, you can't tell. So if I ask for, so I'll call it A1. So 6 plus 2i, if I say complex, 6, 2, that means the 6 is the real part and the 2 is the imaginary part. So I don't exactly know why you'd want to do that, but again, everything that's there in MATLAB is there because at some point some dude was like, man, we totally need to rock this out with this complex function. And I guess I know why. Okay, so say I had a bunch of points, and I think I actually have this in my notes somewhere, but say I had a bunch of points, then I knew all the real parts were like, 1 through 10. And all the imaginary parts were like, I don't know, some other number, like 99 to, I don't know, what would that be? Come on, girl. 90, I think. Yes, okay. So then I could say whatever would be my complex values with the real parts and then the imaginary parts. And look, there I go. I shouldn't have done 10 because that's just obnoxious. See? So minus 5 plus 5. There we go. All right. And so basically what I've done, in fact, is I could use that complex function to create a whole bunch of complex numbers at once. Otherwise I probably would have had to be like, okay, well, it's real parts plus imaginary parts times I, and I guess that would have worked too. But I don't know, just somebody decided we need to know how to do that. So there you go. You can't. Yay! So here are some functions that you can use with complex numbers. So it shouldn't take too much of an imagination, because it's imaginary numbers, imagination to figure out what these do. So if I ask for the real part of A, what do you expect it to come back with? So again, I'm using this A guy up here. A is, well, the real part of A is 6. You're like, I could have figured that out. And what's the imaginary part of A? You'd be like, it's 2. Give me another one. All right, is real. What do you think that's going to come back with? So we had a function in another video that was like, is prime, and it was yes. If it was prime, it said 1, and because that's true, and if it was not prime, it was false or 0. So if I ask, is real A, what do you think it's going to say? No. This is a true, false. So true or false. So true or false, is it real? So is real. 9 or 7 plus 9. Is that real? Yes. So there you go. I could say is real, the real part of B. Be like, yes, is real, the imaginary part of B. It's actually going to say yes because it's pulling off the imaginary part without the I, but I think that's just kind of funny. Yeah, anyway, let's just leave it at that. So for your notes, maybe just don't do that because you're going to confuse yourself. But 7 plus 8 is 15, so clearly that's real. Now, conj of x. So let's do conj of A. You'd be like, wait a second. Wait, what was A again? You're like, okay, A was that. All right. And then conj of A was that thing with a minus sign. And that really, really, really should, like, do something in your brain. Some part of your brain should go, wait a second, because I've seen something like that before. And yes, you have. You have seen stuff like this before. Maybe not in terms of imaginary numbers, but you saw something in terms of like this, where you had a number where you had 5 plus the square root of 2. And your algebra teacher at some point told you that you can't have a square root on the bottom, so what you did is you multiplied by something, but it looked like this. Alright, and the reason that you did that is because if you, on the top you've got 15 minus 3 root 2, and on the bottom, if you FOILed it out, distributed it, you've got 5 times 5 is 25, plus 5 root 2, minus 5 root 2, and then minus square root of 2 squared, which is 2. So you ended up with 15 minus 3 root 2 over some other 25, because those two things cancel out, over 23. Okay? And they told you that somehow this was better because it was impolite to bring a square root on the denominator to a party. So, this thing right here, what you did is you took the thing that was in front of the square root sign and you turned it from a positive to a negative. And maybe by now you remember that was called the conjugate. okay? And in imaginary numbers, if I give you 5 plus 2i, that's basically the same thing, because remember the I is the square root of a negative 1. So we still don't want to bring that to a party. If it's, so we still multiply by the complex conjugate. We call it the complex conjugate now. But what it does is it changes the value in front of the sign. So the sign of the root thing, the radical, because we want to get rid of the radical by multiplying by the complex conjugate, because it makes the inner and outer terms cancel out if we FOIL it out. It's very, very important. So it changes the sign. Let's say this again. It changes the sign, S-I-G-N, in front of the radical. Okay, so it changes the sign in the front of the radical. Now, the radical is the root thingy. So let's look at these guys up here. So what we had minus 3 plus 4i. Okay. So we had 6 plus 2i. We had minus 3 plus 4i. And I believe it was minus 4 minus 7i. Alright, so now take a minute and see if you can write out the complex conjugate of this. It's important. You can't just use functions without knowing what they do, because it really, really, really messes you up, okay? This is a really big deal. Okay, so this freaks people out every once in a while, but this is 6 minus 2i. Alright, the negative in front of 3 stays the same. The only sign that changes is the sign that's in front of the radical. Negative 7, the only sign that changes is the sign that's in front of the radical. Okay, so if we're getting a complex conjugate, the only sign that changes is the sign in front of the radical. It's almost like I keep saying this over and over again. So I'm going to list these here and then C, conjugate of C. So we should see these same things. So we have, I'm going to format compact for a second. So you can see them all. So there's A. There's its conjugate. There's B, there's its conjugate. There's C, there's its conjugate. The regular thingy and the conjugate are exactly the same thing except for the value in front of the negative sign. So just curious, make sure you understand how this works. What is the conjugate? So let's say I have D that's equal to 5. What is the conjugate of 5? What is the complex conjugate of 5? It's 5. Make sure you got that. The complex conjugate of 5 is 5, and that's because it's 5 plus 0i. Its complex conjugate is 5 minus 0i, but that's still 5. Got it? Got it. All right. What if I asked you for the complex conjugate of minus 9i? Okay, so what's the complex conjugate of minus 9i? I'd be like, I don't know. Plus I. Beautiful. So minus 9i. Minus 9i. Remember, that's the 0 real part, and then a minus 9 imaginary part. So that's going to come over to 0 plus 9i, which is again just 9. Positive 9i. So the conjugate is plus 9i. These are important. All of these functions that we're talking about, they're there because somebody needed them. They're there because they're important. They're there because you got to know how to do this stuff. It's just kind of minimal expectations for what we'd expect a programmer to know how to do. So here's something that's kind of fun. What happens when you use a transpose character on complex numbers? So let's see, play this out. And I'm going to pull these guys back. I've just got a ton of stuff on my plate. So see these guys? So I have A, B, and C. Now look what happens if I have A and A transpose, B and B transpose, and C transpose. So look that the transpose character actually finds the complex conjugate of values, which is kind of crazy because say I had all these guys and they were individuals, but they were part of a matrix. All right, and you're just this is why this is important, because say you're just tootling along and you're like, all right, here's my little thing, and it's my matrix, and it's so cool. Look at my really, really cool matrix. Oh man, I wish it was a row matrix or a row vector, and right now it's a column vector. So that's all right. I'm just going to call my new version of A transpose. Look how awesome I am. And then you're like, oh no, everything's messed up. Or maybe you don't even notice because you don't know that it's a possibility, and then you just move on. But it's really messed up. See how this goes plus, plus, minus? Thank you. It should be minus, minus, plus. Or not should be minus, minus, plus. It is minus, minus, plus. And it should be plus, plus, minus. That's not a plus, that's not a plus, and that's definitely not a minus. So the problem is, if you don't know these functions and aren't familiar with what they do, you can really screw up your code. So A supposed to be is you actually have to use the function called transpose, and that will preserve and not give you the complex conjugate. You're like, well, why does MATLAB do that? Probably because most of the time whenever you're transposing a complex matrix, it's because you're going to multiply them together and do dot producty stuff with them, and we'll talk about that later, but you know, just trust me, pay attention to that, because that would totally get you on something. Alright, let's see what else we can do. Alright, now, so we already talked about that. So now, what do you expect to get out of this code? So I'm going to go back to I'm going to title this Absolute Craziness. Alright, and I'm going to pull my A's and whatever's back. Alright, because I like these guys. Alright, so I don't want this guy. So I've got my absolute values and angles of complex numbers. Right? So if I took the absolute value of A, what would you expect it to be? Right? So take a minute and think about this. The absolute value of A, and I think we've even talked about this before if you're watching the videos in order. The absolute value of A is talking about how far A is away from the center. So let's go back to where we drew it. So 6 plus 2i is way over there. The absolute value of A is actually looking at the length of this line right here that I apparently can't draw straight. Alright, so it's actually looking at the length of that line right here. You think, well, how do I find the length of this line? Remember that this is a right triangle, and that the bottom is length 6 and the side is length 2. And I know that a squared plus b squared is equal to c squared. There's my right angle right there. A squared plus b squared is c squared. So that's c. I have c squared is equal to a squared b squared. So that means that c is equal to the square root of a and b, which are 2 squared plus 6 squared. So the square root of 4 plus 36, or square root of 40, which is, well, 2 root 10, but 6.32. Alright, so c is 6.32. So the absolute value of that is actually going to be 6.32. And you say, okay, that makes sense, but what about that second thing? Is that just like the 0.32 and it's kind of messed up? No, it's the angle. And you're like, but that doesn't look like an angle. All right, well, let's think about what this angle is. This angle here, theta, is opposite over adjacent. So the tangent of theta is equal to the opposite over adjacent. So the theta is going to be equal to the arctangent of 1/3. You're like, okay, I can do that. A tan, because remember arctangent is a tan of 1/3. And you're like, but that doesn't make any sense because that's a super, super small angle. But remember that MATLAB thinks in radians. And I think there's an a tan d. There is. So remember the d says degrees, so that's 18.4 degrees. Does that make more sense? You look at that and you're like, yeah, that could be like 18 degrees, I guess. And, you know, if it was a better picture, it could be 18 degrees. But that's exactly what you're getting, is you're getting that in radians. So if you wanted to change that over to degrees, times 180 over pi, and then you've got your angle in degrees instead of radians. So again, love for you to pause the video, go see if you can find the absolute values of these other guys, the angles of the other guys, make sure you get them correct, make sure you know what's going on. That way, you know, you're smart and you'll ace every programming expectation ever put in front of you. So don't just be like, well, I can type it and I can get the answer because I know that you can type. Well, again, I don't know that you can type. I think that you can type. I hope that you can type. But you need to understand how to get this and anticipate what the code's going to be. Specifically because you run into things like that stupid transpose function or that little apostrophe character that totally doesn't do what you expect it would do. So if you can't anticipate that in advance, you're running into some serious problems. All right, so let's look at this guy. So here's the 3, 4, 5. I'm sorry, my pictures are so yucky. That's what you get for free videos. All right, so he goes back 3 and he's up 4. So he goes back 3, he goes up 4, and if you know your Pythagorean triples, that means that's a 3, 4, 5. Not a 30 degree, but a 3, 4, 5. All right. So I'm going to call this guy here, I'm going to call him phi. All right, so tangent phi, arctan phi. Let's call it, come here. Oh, you're not erasing, here we go. So I can say, okay, well, the tangent of phi is 4 over 3, and that's going to be some kind of number. A tan d is 4 over 3. So that's, and I like doing it in degrees because it makes more sense, 53.1. All right, but that's not actually where it is because we're always measuring angles from the positive x-axis. So it's not 53.1, it's actually 180 minus 53.1. So 126. So hopefully, when I run this, and I'll do it times 180 over pi, that's what I get. Yay! It's so exciting when everything's actually worked out correctly. So you see all that check, but yep. So I got the distance is 5, and it's pi over 180. Now the last one. This is all kinds of dirty and messy now, but that's all right. It's all right because I said so. So this guy here, he's back 4. I feel like things are cleaner when we started this. I'm going to get rid of this 3 because he's confusing. So he's back 4 and he's down 7. Alright, and so this is now the triangle that we're looking at. Alright, and this is the angle, and I'll call him, I'm running out of angles. I don't care, I'll call him psi. Alright, so psi, I don't know why I started with the angle, but I did, but psi is the opposite over the adjacent. So the psi is equal to the inverse tangent of 7 over 4. Yeah, 7 over 4. A tan d of 7 over 4. That's 60.2. But it's actually, since we're measuring from here, he's 180 plus 60.2. I'm sorry, this is really messy. It's kind of embarrassing now, but I'm kind of committed. So it's 180 plus arctan of that. So it's 240 degrees. So this guy, I expect him to be at 240 degrees, and his absolute value, his distance here is going to be the square root of the sum of the squares. He's the square root of the sum of the squares, which is 7 squared plus 4 squared, which I don't know what that is. Square root of 7 squared plus 4 squared, 8. Alright, so I expect to get an answer that looks like 8 and 240. So, 8 and, oh, well, who knows. You're like, oh no, it says negative 119. Alright, well, let's add 360 degrees to that. There's my 240. So it just gave it to me in a different quadrant. Instead of giving me the positive rotation and giving me a positive number, it gave me the negative rotation and gave me the, I mean, you can still do that. It just, the answer is negative. So I could have said that this one was 180 minus 60 point, not even 180, really, negative 180 minus 60.2. So 60.2 plus 100. Anyway, that would have given me the same answer as well. But anyway, so that should theoretically give you an idea of what we're looking at here. And I think that's all we really need you to know how to do. But that should be a good start for your complex numbers.